Hello, my name is Emilio. I am an application scientist at Lakeshore Cryotronics. Today we'll be talking about the M81 source and measure system, specifically the CMR common mode rejection feature of the balanced current source. The experimental setup consists of a current source and a voltmeter measuring a 10 milliohm resistor. So in this application, we'll be targeting measuring low resistances with high accuracy and the problems that arise when you add inline resistance to one of the leads. We will be sourcing 100 microamps through this 10 milliohms resistor using our BCS10 module, and this should generate a signal of 1 microvolts that will be measured with the voltmeter VM10. We will be able to see on the screen that we can detect with very high accuracy the 10 milliohm resistor, and then we will introduce a problem in this experimental setup, which is adding a large inline resistance of 10 kilo ohms. What's going to happen when we do this is our balanced current source, as a default, will distribute the 100 microamps equally through the circuit. And this will generate a common mode of 0.5 volts at this node. The common mode of 0.5 volts on top of the small signal that we're trying to detect of 1 microvolt, this common mode will generate error and inaccuracy in our measurement of the 10 milliohm resistor, and we're going to see this resistance change to 9 milliohms, causing a 10% error. What we're going to do next is activate the CMR feature and bring our connection to this point, which is going to provide feedback to the current sources to distribute the currents in such a way that this point here is driven to 0 volts. So this point will become a 0 volts common mode, and it's going to remove the artifacts that was causing error in our measurements. And then we'll be able to see this error go down to 0%, and we'll recover our 10 milliohms reading. We're going to be sourcing 100 microamps through the 10 milliohms resistor using a sine wave shape at 17 Hz frequency. For the first part of the experiment, we're going to have the CMR feedback source set to internal, which will distribute the currents in an equal way. For the measurement channels, we're going to use the lock-in mode to detect a small signal, and we're going to use the parameters of 24 dB for the roll-off of the lock-in and 1 second time constant. As you can see, because we haven't added the 10 kilo ohms inline resistance, we're able to read with high accuracy the 10 milliohms resistor to an accuracy of less than 1%. Now I'm going to introduce the 10,000 kilo ohms inline resistance, and we're going to see on the screen how the signal deteriorates. As you can see, by adding the 10 kilo ohms inline resistance, the common mode that has been generated at the voltmeter adds inaccuracy to the measurement of 10%. We now have a reading of around 9 milliohms. Now we're going to activate the special M81 feature of the common mode rejection. By changing the CMR feedback source from internal to external. And we can quickly see how the signal goes back to the expected 10 milliohms result.